We're going to take a look at polar coordinates. Okay, quiz is when again? Monday. So, for polar coordinates, now these will look very, very familiar because they're very similar to vectors. Except for, instead of magnitude and direction, you get radius and inclination. Okay, or just angle if you like. So, you're still going to have going from the origin. It's still always going to be going up from the x-axis. They just rename it to polar axis. Honestly, if you still call it x-axis, that's fine. The coordinate is made up of radius and angle. So the distance out from center. Now, this is not a directed ray, though. This isn't an arrow pointing out, going from the origin to there. It's literally just the dot at the end. So you have a directed distance from O to that p-value and a directed angle. Okay, and that will always be just like the unit circle, counterclockwise, as far as the number goes. So if I give you something like this, well, where on that graph would 3 negative pi over 3 be?
On the third line, and then go down.
Down about 2/3 of this quadrant. It's going to be the fourth quadrant because of the negative pi over 3. And it's 3 concentric circles out. So it'll be about there. What about for B?
2 circles out and closer to the x-axis.
Yeah, closer to the x-axis. 2 circles out. And for C?
Other side, opposite.
Yeah, it's just a flip over, reflection over that polar
Oh,
axis. Not bad? Now, just like with vectors, you can describe these things multiple ways. So if I have 2 3 pi over 4, where is that at first off?
Out on left side. And
Yeah, second quadrant, so left top and dead center. It's 2 out. So right in the middle of that quadrant. Now, how else could I describe this?
Negative something pi over 4.
So keep the 2 and then negative, what would that be?
Negative 5 pi?
So 1 pi, 3 pi, 5 pi over 4. Any other way I could do that?
you could just go around all the way again, couldn't you? Like 2 and then.
Well, but it's between negative 2 pi and 2 pi. So you can do another full rotation. But there are 2 others. Think about with vectors.
Like add 2 together, so it'd be like 2 comma.
No, you couldn't just add 2 vectors together, or 2 polar coordinates together, sorry. What if I had this? What if I overshot and accidentally went to 7 pi over 4? Without traveling any more rotation, how could I get back to that point? What? Negative 2. Negative 2 just means you go in the opposite direction of what this is indicating. So 7 pi over 4 indicates the fourth quadrant. Negative 2 then goes back through the origin to 2. Remember doing that for vectors?
Yeah.
No.
Okay. What's the last way I could describe it then? Yep, negative 2 and negative pi over 4. For the same reason. Does that make sense? Alright, so if I describe this by its current position, it's either 2 out along this 3 pi over 4 vector, right? Or that's the same as negative 5 pi over 4. You good there?
Yeah.
Okay. Or the other way I can describe it is if I think about it, instead of thinking about this direction, what if I thought about this direction? Well, the 7 pi over 4 is in this quadrant, negative pi over 4 is this quadrant, same thing. But instead of going in a positive direction along it, either 1, 2, or 3, if I was going this direction, but it's a negative radius, instead of going along that line, I'm going to go opposite that line, 2. Because it's negative 2. So I'm going to go back through the origin. So what this is indicating direction, right? So if the direction of travel is this way, then if that's a positive number, it means go along that direction of travel. If it's a negative number, it means go the opposite of that direction of travel. So the theta indicates I would be going this way, right?
Yeah.
The negative 2 means I'm not going to go along that. I'm going to go the opposite direction because it's negative. If it was a positive number, I'd be somewhere along that line. Does that help? Okay. Now, you'll often be given these things in either rectangular or polar, and you'll need to be able to convert from one to another. The nice thing about it, it's a right triangle, so all your right triangle relationships work. So if I have x and y as far as a rectangular coordinate, and I want to find the radius, all I need to do is Pythagorean theorem. The radius will always be the hypotenuse. That'll work every time. What if I wanted to find theta? What would I have to do there? Well, what relationship do I have? If I know what x and y are, how could I find theta? Tangent. Tangent of this theta will always equal y over x, right? Vertical over horizontal. That'll work every time. The other direction is a little bit harder to see. Because the other direction, if I'm given radius and theta, so in other words, I know the angle and I know the hypotenuse, how could I find y? Sine. Sine of theta is opposite over hypotenuse, right? So if I have sine of theta is equal to y over r, then what's y equal to? Don't overcomplicate that. Solve for y. R sine theta. You just move the r to the other side. For the x, instead of sine, you use cosine. So you end up with these formulas for conversion, but honestly, they're, to me, fairly instinctual if you're comfortable with the right triangle stuff. And because of those of SOHCAHTOA, well, other direction, but SOHCAHTOA, those formulas work. Okay. So, to use those a little bit, if I want to convert this coordinate, or these coordinates to rectangular, these are polar. Now, honestly, you don't always have to use the formulas either. If you can see it without the formulas, fantastic. So what about 4 and 3 pi over 6? How would I convert that to rectangular? Well, formulaic-wise, my x value is going to be equal to 4 times cosine. Well, what's 3 pi over 6? Pi over 2. What's cosine of pi over 2? 0. So x is 0. For y, 4 sine pi over 2 will give me what? 4. It's 4 times 1. So the coordinate would be 0, 4. Which, stop and look at it for a second. You don't even actually need to do all that, because this is 4 out from center, right? And pi over 2 up, right?
Yeah.
So you could do that one without. The next one would be a little bit hard to do without. Go ahead and find your rectangular for this one. Same methodology. So what do you get?
X equals square root of
Hmm?
3. X equals square root of 3.
Anybody else get square root of 3 for x? Yeah. So that's going to be square root of 3 over 2, and then the 2's just cancel off. So that means y is going to be 1. So you have the square root of 3 and 1. Not too bad? Okay, going the other direction. What if I have these two rectangular coordinates and I want to convert them to polar? Well, for polar, I need what two things? R and theta, radius and theta. So, radius, how do I find it?
X squared.
So in this case, r squared is going to be equal to 2 squared plus 2 squared. In other words, r squared equals 8. So what's r?
Square root of 8.
Simplifies to
2 squared.
2 root 2. For theta, theta is going to be equal to the inverse tangent of y over x. Yep. So what's the inverse tangent of 1? Pi over 4. Now potentially it could be 5 pi over 4 as well, right? Why do I know 5 pi over 4 is incorrect? Yeah, so unless you adjust the radius, you're going to want to use the regular pi over 4. So you get 2 root 2 and pi over 4. For the next one, well, let's do this one without. What's my radius going to be at negative 1, 0? 1. You're 1 out, right? What's the angle going to be?
0. No. 180.
Pi, which is the same as 180. So I could just write 1 and pi. Now somebody said 0. What would it be if you did 0 degree or 0 radians? What? It'd be 1, 0?
It would be
Because remember, negative 1, 0 is over here, right? So that's pi rotation 1 out. So this at 0 would be going negative 1. So actually, your rectangular and your polar are the same in this case. At least one version of it.
wait, why would it be 1, 0?
No, negative 1, 0. Because 0 radians, or 0 degrees if you like, is this way, right?
Yeah.
So then this is going back through the origin 1. So it's negative 1 radians along with 0,
Oh, there.
or negative 1 radius along with 0 radians. Well, it's also negative 1 x coordinate along with 0 y coordinate. Just one of those oddball ones where that lines up. It's pretty much the only one that I can think of. Well, no. 1, 0 would do the same thing. So, here's where it can be a little bit confusing at first. Describe the graph of each polar equation and find the corresponding rectangular equation. So if all you're given is r equals 1, what will that graph look like? A circle at 1, because the radius could be, or the angle, I mean, could be anything. So it's literally just this circle. Then how would I write that as an equation? Hmm? Yeah, x squared plus y squared is equal to 1. What about for the next one? How would I show theta equals pi over 4? Start at 0 and then go which way?
Out, but don't stop at any of them.
Yeah, split the first quadrant in half. Would that be it?
No, all 4. No, all of the second one.
Yeah, also go back through the origin because theta could be any, or theta is locked in, but r could be anything. R could be positive or negative. So it actually generates a line. And what would the equation of that line be? Yeah, y equals x. This one's a little bit more challenging. What about r equals cosecant theta? Hmm? R equals cosecant of theta.
Inverse sine
It's 1 over sine. It's not inverse sine.
Why would it be inverse sine? Or sine?
You said inverse sine.
Yeah, I
Cosecant is 1 over sine. You said inverse sine.
Oh.
It's not the same thing. So that means if I move this around a little bit, r sine theta is equal to 1, right? What's r sine theta? It's y. This is y equals 1. What's the graph y equals 1 look like?
Horizontal line of 1.
Horizontal line at 1. So it's literally just this. Those ones are a little weird when it's cosecant and secant, but cosecant will actually generate a vertical line for you. Questions? That's actually all there is for this section.
Is there a way to graph that on calculators?
I don't know. Is there?
I remember something Mr. Schmidt told us.
Okay,
Okay.